In this video, I'm going to show you how you can solo mine Digibyte to your own node. I've been getting lots of requests about how to solo mine Digibyte using devices like the Bitaxe Gamma or the Canaan Avalon Nano 3s and things like the Lucky Miners, various home mining devices. So today I'm going to walk you through how to set up basically your own solo mining pool that you'll be able to run on your home network, or you can host it in VPS if you want. And you'll be able to point all of that hardware to it and actually solo mine Digibyte. Now, what I'm going to show you today will work with any SHA-256 coin. So this will work with Digibyte. It'll work with Bitcoin Cash. It'll work with Bitcoin. It'll also work with Fractal Bitcoin. BSV will require more intensive hardware if you want to do that one. But in a nutshell, any SHA-256 coin, it will work with. Now, before we jump into the steps, I do want to review kind of from a functional process what we're going to be covering, and also touch base on the hardware that we're going to be using. So right off the bat, I've put together a list of kind of functional steps that we're going to be running through. So this will hopefully give you an understanding of the steps that we're performing technically and why we're performing those. So I'm going to start the video out talking through these. So we are working with a fresh instance. I actually have MMPOS installed on this system. We're actually just using a really old laptop. It's got a 4th gen i5 in it, and I believe 16 gigs of RAM. So what we're going to do is we're going to create a swap file. This is optional, but I like to do this in case we want to run multiple nodes in the future. Makes things easier. Then we're going to install Docker. And then for Digibyte, they use the RPC auth protocol. You can't use RPC username and password like I've covered in previous videos, but they provide you a script you can run to generate the credentials. So we're going to walk through that. And then we're going to set up the Digibyte node config file. And then for the purposes of this video, so that I can show you what it looks like when you hit blocks, we're going to be running the Digibyte node in testnet mode. However, I will show you the difference in how you would run it on mainnet. In fact, by default, it would run on mainnet. There's just a couple extra parameters you can set to run it in testnet, which is what we're going to be doing. We're going to be creating a pool wallet for that node, and then we're going to be creating a address that our pool wallet will be kind of using as its controller wallet. And then we're going to download. I already have a massive list of a coin database. We're going to be downloading that and leveraging that. And then we're going to be creating a config file for Miningcore, and we will be using Miningcore in this. Then we're going to install a Postgres database engine. We're going to set up PG admin, which is going to allow us to manage that Postgres database through a web UI. We're going to create the Miningcore database using the web UI. Then we're going to run Miningcore. We're going to run the web UI. This is optional, but do recommend it. It makes it easier to periodically check in on how things are going. We're going to generate a testnet mining address, and then we're going to configure our miners to point to Miningcore. Now, pretty much all of these steps I've covered in previous videos, my Miningcore videos. However, today we're going to walk through them specific to Digibyte. And then once we get down to the bottom, real quick, I just want to touch base on the hardware that we're going to be using. So we've got a Bitaxe Gamma that we'll be using. Right now we've got it set around 1.1 terahash. And right now it's actually pool mining, or it's solo mining to my pool, which I have for Digibyte and also Bitcoin Cash. You can see we've got a few people over there solo mining with their devices. So if we take a look at miners, you can see that this 2 terahash, this is actually my Bitaxe Gamma is pointed here right now. And then I also have a Bitcoin Cash solo pool that I spun back up. And this is what I have the Canaan Avalon Nano 3 pointed to, which is our other device. We've got mining around 4 terahash a second. Now, if you are interested in any Bitaxe devices, the one thing that I would caution you with, it's not a deal breaker, but I recommend, and what I personally run are the Gecko Science Edition ones. These have a little bit better circuitry on them. However, and better components. And what you're going to notice is they also have a 4-pin fan connector. So if we take a look at this, and then we also take a look at one at Solo Satoshi, they both have the 4-pin fan connector. But if you look at the ones over at PlebSource and Bitcoin Merch, what you'll notice is this little connector here. It is a non-standard. Let's see if we can zoom in here a little bit. What you'll see is that is a non-standard pin connector. So you can see they actually had the option to solder in the connection here, but they opted to go with kind of that little proprietary one. It's not that it's necessarily proprietary, it's just it's not a PC computer PC standard. So if you're going to swap out Noctio fans, then you have to start working with adapter cables, anything like that. And so while these may be a little bit cheaper, they're $150 over at PlebSource. I do recommend either going with Solo Satoshi, you can say they're $180 here, or over at Gecko Science, you can get from the official Gecko Science website. They're $175. This is actually who I bought mine from on Black Friday. They were running a sale. I believe I paid like $130, $135. I don't remember the exact figure, but been super happy with this one. So highly recommended. And then obviously the Nano, right? There's newer models out now, but the model that I have actually won in a giveaway from Geek of All Trades that he was doing courtesy of Cool Dragon. And so over on Cool Dragon's website, you can get those as well. They're $159 right now. So not a bad deal for 4 terahash, 150 watts or 140 watts. They do have that newer model, I believe is 6 terahash. I do not have one of those though. I believe it's the 3S. We're now able to run the actual setup commands. So we're going to start with a sudo apt update -y. We're going to update our packages. And then I'm going to do a df-h. I'm going to see how much disk space we have free here. We can see we're working with about 100 gigs. Now, one of the things I want to mention is blockchain sizes can be fairly large. However, you have the option to run in a pruning mode. And when you're running a mining node, you don't need the full history. You only need kind of the current snapshot of the blockchain. And it needs to be kept up to date in real time, obviously, but you don't need all that back history. So you're able to prune it and you're able to save tons of storage space. Now, if this is your only node that you're running and you only if you only care about mining, getting the rewards, you don't care about being able to maintain an entire immutable ledger on your own system, then you can turn pruning on. I always recommend running one node as kind of a full archival node, but that doesn't have to be the node that you mine to. So for us, we're going to be doing pruning. So 100 gigs is going to be plenty of storage. So we're going to do sudo. So we're now going to create the swap file. So to do that, we're going to sudo fallocate -l, and we want to do 16G for 16 gigabyte. We're going to put it /swap file, and then we're going to do a sudo chmod 600 on that file, and then we're going to do a sudo mkswap to actually make that a swap. Do that, and then we're going to do sudo swap on /swap. And then we can just append this to the etc fs tab file. You can do that manually, or you can just run this command. That'll do it for you. And again, all these commands will be in a paste bin in the description below. So it'd be really easy for you to just copy and paste. But for this, we're going to do sudo t-a -etc fs. What this is going to do is this is going to append a line with this content which points to the swap file. It basically tells the system on boot up to auto mount our swap file as a swap partition. So now that is up. If we do a free-m, we should see a swap file now, which we do. So we've got 16 gigs of real RAM, and then we have a swap file of 16 gigs. So in theory, we've got about 32 gigs we can work with. The next step is to install Docker. So that is simple as doing a sudo apt install docker.io. Hit Y. And this may take a minute to download and install the Docker engine. Once Docker's installed, we can just test that by doing a sudo docker ps-a. And we can say we don't have anything because we don't have any containers running. But the engine is installed. Now we want to set up some folders. So we're going to do sudo mkdir. I like putting everything at /data. And all the scripts that I provide down below is going to assume you're going to do the same. So we're going to create a /data folder. And then we're going to create a /data/.dgb. This is where we're actually going to store the blockchain data for Digibyte. I like to do dot and then whatever the ticker of the coin is. So if it was BTC, we would do .btc. And then we're just going to do change directory, we'll do tilde. This will take us back to our home folder. And then we're going to run a wget command. Now I am going to copy and paste this one in. This is to Digibyte's GitHub. And this is their official RPC auth Python script. So we're going to go ahead and download that. And then we're going to run Python 3 RPC auth.py. And it takes 2 arguments. You can give it a username and a password. And what it's going to do is it's going to generate kind of a key for you, if you will, or a hashed password. So we're just going to call this, for simplicity, we're going to call this pool user and pool password. And that's going to give us this whole RPC offline. We want to go ahead and copy this. We're going to need this later in the steps. So I'm just going to copy that over into a notepad file. And then the next thing we want to do is we want to create our config file for the Digibyte node. So to do that, we're going to do sudo nano /data /.dgb /digibyte.conf. Now, the way Digibyte works, whether you're running mainnet or testnet, this is the path for the config file. The only difference is that if you're doing this, you can actually use the same config file for both. You just have to specify a attribute, and that attribute is test. So if I put test here, anything below this will apply to the testnet network when I'm running it on testnet. If I put it outside of it, it'll apply to mainnet. So for me, since we're only going to be running this in testnet, I'm going to do this under test. If you were doing mainnet, you wouldn't need that test tag at all. But let's go ahead and add that in. We're going to do server equals 1. Listen equals 1. We're going to do RPC port. I'm going to run this on port 9001 for simplicity, but you can run it on any port you want. And then we're going to do RPC allow IP equals 127.0.0.1. That'll make sure that only this system can connect to the daemon, the node software. So if you're running your pool software, Miningcore, on a different system, you'd want to make sure this IP address was in there of the system Miningcore is on. But I am running them both on the same system. Now, specific to Digibyte, you have to specify the algo. So because there is 5 different algos within Digibyte, whenever you run a node, that node can only run on one of the algorithms. So we're going to do SHA-256D there. And then that RPC auth that was generated from that Python script, we're going to go ahead and copy and paste that in here. So it's going to be RPC auth equals, and then it's going to be that username we chose, pool user, : and then the hashed password it generated. And then we're going to do prune equals 550. This will basically enable pruning, and it'll keep it at that 550 megabyte threshold. And then we're going to do wallet equals default. What this is going to do is, in a later step, we're going to be creating a wallet, and it's going to auto load that anytime the Docker image restarts or anytime the computer restarts. So that is all we need for the config. So we do Control X, Y, enter to save. Now we're ready to actually run the Docker container rather for the Digibyte node. So to do that, we're just going to do sudo docker run -d --network host --restart always --log opt space max -size equals 10M. This will make sure it rotates the logs and purges any old logs. And then we're going to give this a name of just DGB. Important part here, we need to give it a volume mapping. We want to map /data/.dgb. That's the blockchain folder we created. And we're going to map that to /root/.digibyte spelled out. And then we've got to give it my Docker Hub account. So that's going to be the retro mic /nodes:/Digibyte. And this is the important part. If you're running mainnet, this is the end of the command. You would hit enter and you would run it. If you're running testnet like I am, then you're going to type Digibyte d space -testnet -print to console. And what this is going to do is this is going to run it in testnet mode. So we're going to go ahead and hit enter. It's going to go out and download the Docker image, build and run the container. All right, so now the container should be started, and because we did restart always, if the system ever crashes, anything like that, it should auto restart it. Now, to validate that it's running, we can do a sudo docker logs DGB, and we can see that it is running. And if we do a sudo docker logs DGB -- follow, this will follow the logs in real time. And we can see printing block store. Obviously, this is a fresh block store. There was no data on the system yet. So we're going to give this a minute. It's going to build the files. It's going to go out, find other nodes to connect to, and then it's going to start downloading the blockchain. And there you can see it's downloading the blockchain now. It's just started. This will take a while. It won't take as long as mainnet because there's really no transactions on testnet. So be a lot of empty blocks, not a lot of storage is needed. So just give this some time. It could still take an hour or two to sync everything, but it's not going to take an extremely long amount. This is older hardware, so we're going to let this sync, and you can either leave the screen up or you can do Control C if you want to exit the following. And then if you ever want to reattach, you can just do the same command again. So we're going to let this sit, let it sync up. And once it's done, we're going to continue with the rest of the steps. The node is all synced up. You can see our progress is 1.0. We're at the current block height. So we're going to do Control C. And now we need to create the wallet. So to do that, you're just going to interact with that Docker container. So we're going to do a sudo docker. We're going to do exec this time. DGB, which was the name of our Docker container, and we're going to run Digibyte -CLI -testnet. And what I like to do is I like to run git balance. This should give us back an error telling us there's no wallet loaded, which this will be the first time you spin this up. It doesn't create a wallet by default. So what we do is we do create wallet. And if you remember when we set up our config file, we did wallet equals default. So we want to name this default. Hit enter. That's going to go ahead and create the wallet. Now, if you run get balance again, now you can see we've got a 0 balance. It created the wallet. It also loaded it. Now, anytime the Docker container restarts, the node software restarts, it'll read that config file and it'll see that we put wallet equals default, and it'll auto load this default wallet. Now what we want to do is we want to create an address that our pool is going to use for actually receiving all of the block rewards and then issuing payouts to our miners. So to do that, we're going to do the same command, except instead of get balance, we're going to do get new address. You want to do a space. You want to do double quotes with no content in them. So double quote again, space, and then within double quotes, we want to do legacy. What this is going to do is this is going to create us a new address against the default account with a type of legacy, which is what Miningcore needs. So now we've generated this address. You want to copy this. You're going to need this coming up in a few steps. So we're just going to go ahead and copy that over into a notepad file. And now we need to create a couple more folders. So if we take a look, we previously created just the DGB file, or DGB folder at /data. We now need to create a Postgres one. So we're going to go ahead, we need to do sudo mkdir there. So we're going to go ahead and create a Postgres folder, and then within that, we're going to also create a data folder. And then we are going to also create a Miningcore folder. So it's going to be /data/.miningcore. Now we're going to move into that Miningcore folder we just created. And we're going to download our coin config. So I'm going to just copy and paste it over here. This is the URL you're going to use. This is going to download a coins.json from my GitHub. Now, this contains the coin definition for most of the known coins right now. And these are going to be the coins that Miningcore is going to support. And then you don't need to modify that file at all once you download it. But then we need to create a config file for our pool. So we're going to do sudo nano config.json. And once again, I will leave the contents of this file for you to copy and paste, which I'm going to do now. And then we're going to modify some things in it. And I'm going to walk you through what each of those lines are for. So starting off the bat, we'll just kind of walk through this if you're not familiar with Miningcore. You've got a logging section at the top, a banning section, notifications, which I typically just disable. The persistence, this is the database connection. This is where you're going to specify the database name. This is the database name. This is the username for Postgres, and this is the password. For purposes of this video, we're just going to leave all three as Miningcore. We'll be setting that up here in a minute. Just whatever you set those, remember what those are. This Coinbase string. You may be aware that services like mempool.space, they will show you who mined a block. There's part of the block generation transaction that you can put in whatever text you want. And it'll kind of signify that, hey, you created that block. That's what this Coinbase string is. So this works on all Bitcoin forks for the most part. So things like Bitcoin, Digibyte, Bitcoin Cash, Vertcoin, Gertzelcoin, various coins it will work with. So if you specify it here, any coins that you run on your pool will use this tag. So this is similar like what CK Pool or ViaBT's or Foundry does. So for us, I'm just going to say, I'm going to adjust this to mined by RMT demo so that we can validate that that's working. And then API port, we'll leave that as 4000. I would not change this. The web UI is already set up to use this port. If you do need to change it, there are some other downstream impacts to that. Going down to the pool section, this is where you define the pool. Now this is an array block, so you can have multiple pools in here For the purposes of this video, we're only going to set up one pool. I may do one in the future where I show you how to add like BTC, BCH into the existing config file. And for now, we're just going to do DGB. So want this to be enabled. The coin has to match what's in the coin file, which is Digibyte-SHA-256, because there are multiple Digibyte algos. And Miningcore actually supports, I believe, all of them, all 5 of them. Now, if you remember, a couple minutes ago, we created a wallet address. We need to grab that. We want to put that here in the address. This is the wallet address that the pool expects all of the blocks to hit. And then you can set up what's called a reward recipient. This is almost like a operator fee. And I typically set this to the same wallet address. And the reason I do this is because this will take the block reward. So in this example, this would take 0.01% of the block reward and essentially keep it in that wallet address for every block. And this way, I know that the pool wallet has substantial funds to pay any transaction fees to send out payments. I don't like keeping a lot of money in the wallet address, so I try to keep it as low as possible. But you want to make sure that you always have a kind of a steady feed of funds in that wallet. So 0.01% is a great starting point there. A lot of pools will do 0.5% or 1%. This is an array, so you can set up multiples here. You could, if you wanted to, you could come in here. We could copy this, and we could add a comma here, enter, and I could have this pay 0.01% to that pool address, and then I could have, say, some other wallet address that is going 0.09%. Now, essentially what would happen is our pool fee would be 1%, or 0.1%, rather, and 0.01 would remain in the pool wallet to cover any future transaction fees. And the remaining 0.09 I could send to, a wallet somewhere else, like a cold storage wallet, anything like that, if you wanted to. Go ahead and get rid of those lines. Moving down, enable ASIC boost. True. You need this in order for the Bitaxe to work with Miningcore. Without this line, the Bitaxe will not work. It'll connect and then it will disconnect, and you won't ever get any shares or really any work being done per se. So you definitely need that line in here if you want to support Bitaxe. A lot of other hardware will work without it, but it's kind of a fallback on some of the modern hardware to make sure they all work. And then, and we're going to be testing with a Bitaxe today as well as a Avalon Nano 3, so we need to have that enabled for this test. Here you can set up any of your banning. This port here, so port 3001, this is going to be the port that you're going to mine on. This is what the miner is going to connect to. And very important to understand that. Very important to have a listen address of 0.0.0.0 or the IP address of your system. Either way is fine. This is going to be your difficulty adjustment. You can adjust this however you see fit. And then on the daemon side of things, this is going to connect to port 9001. If you remember, we set up that RPC auth and we passed in a username of pool user and a password of pool password. That's what you need to set here. And then on your payment processing, we've set out the payout scheme to be solo, and it's enabled, meaning it's going to run payouts. So at this point, everything is set up properly. So we're just going to do Control X, Y, enter to save. And now we need to set up the Postgres database engine. So I'm actually going to copy and paste this command because it's a little bit longer than most. But essentially, we're going to do a sudo docker run. We're going to run detached. It's going to be Postgres. We're going to listen on 5432, which is the default Postgres port. We're going to give it a username of admin. This username can be anything you want. Just make sure you know what it is. Our password, I'm just going to do this for the password. Our database is going to be master. That's going to be the default database. And we need to map that volume of /data /.postgres /data to /var lib postgresql /data. And we're going to name the container Postgres. And one thing that is missing here that I do want to add real quick is going to be the max log size. So I like to include this max log size in all of my Docker containers, just so that the log files never get overfilled. We're going to go ahead and hit enter here. That's going to download and start the Postgres engine. And once that's done, then we're going to set up pgadmin. This is going to allow us to manage that database through a web browser. And here the important thing is, so once again, we're going to do sudo docker run -d. We're going to name it pgadmin, restart always, specify the log file. We're going to map this port 8080 to 80. So we'll be able to access our web UI for the database management on port 8080. That's going to be whatever port you want. pgadmin default email. We're just going to do admin@admin.com. And our default password is going to be that. It's very important. This is what you're going to use to log into the web dashboard to manage the database. It's kind of like a two-step authentication, which I'll be showing you here in a minute. So we'll go ahead and hit enter. That's going to set up the Postgres admin web portal for us. Now that that's downloaded, we know what our IP address of our system is. So we're going to hop on over to the web browser, and we're going to go to 80:8080. So it's going to be the IP address :8080, and this may take a minute while it's still starting up. Okay, there you can see that it started up. We're going to do admin@admin.com for the username, and then our password is going to be capital P at @ssw0rd. Go ahead and log in. And now we need to register the server. So to do that, we just right click on servers, go to register, select server. You can just name this local, name doesn't really matter here. On the connection tab, we have to give the IP of our system. Even though it's running on the same, we still need to give the IP there. And our username is admin. And our password. And these are the credentials that we specified in that first Docker command with the Postgres engine. And I'm going to say save. That's going to connect to it. If I expand this, now we want to set up a login. So I'm going to do right click on logins to create login group role. And we're going to name this Miningcore. And then under the definition, I'm going to give it a password. This needs to align with what you set up in the config file. So for me, I'm just going to do Miningcore for the password as well. And under privileges, you want to make sure that you select can login. It's all that you need to select there. Go ahead and hit save. Now we want to expand databases. We're going to right click, create database. We're going to call this Miningcore. Once again, this name has to match what was put in your config file. And then the owner, we're going to scroll down. We're going to select Miningcore here. And everything else you can leave as default. Now what we want to do is we want to right click on Miningcore. We're going to hit create script. And then we're going to just select everything that's in here and delete it all. And I've provided down below the entire schema that you want to run. You can also get this from the GitHub repository, but just for convenience, since it's a one-time command, I have included it below. So we're just going to copy and paste that in. This is going to create the data structure for the Miningcore database. I hit execute. It's going to run it. So now if we expand schemas, you can see we've got public, and if we expand tables, now you can see we've got our tables for Miningcore. So we've got whenever blocks get found, the pool stats, the miner stats, the balances, miner settings. This is where you can set payment threshold, payout thresholds, all of that. That is all there, as well as where it's going to store the shares. Shares aren't going to be that important because we're in solo mode, but if you were in pool mode, it would matter. Okay, so now the database is set up. Optionally, if you wanted to turn off PG admin, you could do that. So if we take a look at sudo docker ps-a, we are running 3 containers right now. So the Digibyte node, Postgres, and PG admin. If we wanted to turn off the web UI, just from security standpoint, we could always do sudo docker stop PG admin. And that would stop the container. And so then if we try to go back over to this web UI, hit refresh, reload, there's no page because we've stopped that service from running. And then alternatively, if you wanted to start that back up because you're trying to manage something, you could just do sudo docker start PG admin. Okay, moving on to the next step, it's actually just running Miningcore. So to do this, once again, I'm going to copy and paste this because it's a little bit of a lengthy command. But all that you're going to do here is you're going to do sudo docker run. We're going to detach. The name's going to be Miningcore. Restart always network of host. And we're going to do a volume mapping of data/.miningcore/config.json. So this is our pool config file. We're going to map that to app/config.json. Then we're going to do the same thing for the coins.json file. And then the Docker container is going to be the retro mic/miningcore. You're going to go ahead and hit enter here. And this is going to download the Miningcore Docker image and run it. Once that's done, it should have started up the mining pool software. We can validate that by going sudo docker logs space miningcore. Hit enter. And this is what you're going to see. So you're going to see that it has actually started up a Digibyte. It's connected to the testnet network, which is great. And you can see the network hash rate's only 16 mega hashes per second. This is because there's probably only 1 or 2 miners on testnet just to kind of keep it alive. So now we can set up the web UI. This part is optional. Technically, you don't need to do this part. You could point your miner to the IP address, the port number, which is 3001, and it will mine away. However, to be able to monitor it, see stats, all of that more visually, we're going to set up the web UI, which is super easy to do. So we're going to run this command. We're going to do sudo git clone of my web UI GitHub, and we're going to save that into /data/.miningcore web UI. Go ahead and hit enter. And then we're going to run a Docker image. It's going to spin up a web server. So we're going to run this on port 80. And it's just going to be, we're going to name it Miningcore Web UI. We're going to give you a volume mapping to that folder we just cloned into. We're going to map that to user share nginx/html. We're going to go ahead and run this. And now if we hop on over to our dashboard and we change this to port 80, there you can see we've got our dashboard that shows we've got a Digibyte pool. This will make things a lot easier. If we click into it and then we go down to connect, this is the Stratum URL that you want to use. So we can copy this. I'm going to hop on over to a Bitaxe. So this is a Bitaxe Gamma. And I'm just going to change. Now on the Bitaxe, you don't actually specify the protocol. So you just do the IP address there. Then it's going to be port 3001. And we need to have a mining address. I don't have a testnet mining address. So what I'm going to do is we're just going to create one on the same system. Because we're using testnet, we can do this. So we're just going to do docker exec DGB, and then we can do Digibyte CLI, testnet, get new address. We need to do a sudo here. Okay, this is going to give us an address. Now, if you notice, I didn't do legacy here. This can be any address type. It doesn't need to be a legacy address. The legacy address is only for the pool wallet. So we go ahead and copy this. We can put this in here now and do .bitaxe. And our password, we can just do X here. Go ahead and hit save. And you have to hit restart in order for the miner to restart and connect. And we can hop back on over here. And this can take up to 5 minutes to reflect. But if we hop on over here and we do docker logs on Miningcore -- follow, we can see that it already connected and it has already found blocks, and it is finding blocks rapidly. So if we hop back on over here, you can see the workers connected. You can see we already found 4 blocks on testnet. Actually, more than that now. We're up to 5 now. So what you'll see here is, and we'll let this run for a couple minutes just to make sure they confirm, but we're basically hitting every block for the most part, because what is happening is there was only 17 mega hash on the network, and we are now hashing away with 1.2 terahash almost. Once it actually ramps up, we'll be getting a little bit over a terahash most likely. And you can see basically every share that we're hitting is the block. So we will just, we'll let that run here for a couple minutes. But that shows you that you can certainly hit blocks with Bitaxes using Miningcore. And we will, in fact, now that we've hit a few blocks, I'm going to go ahead and stop the miner. We'll go ahead and switch it back to my other pool. Before we switch it back to the pool, we'll just go ahead and show you the stats. So if we come over, go to dashboard, we can plug in our wallet address. We go load wallet stats, and there you can see our hash rate, a little bit over a terahash. It doesn't have pending balance yet, because it takes about 5 minutes for those stats to update. But once those update, we will see once some of those blocks confirm. You can see we still don't know what the reward is because they are still unconfirmed. It will take, like I said, about 5 minutes for all those confirmations to periodically update. And then that will reflect, and that will go to our wallet. Now, once again, we are on testnet right now. That means anything that we mine doesn't have any value. It doesn't translate to anything on the main net. So just keep that in mind. Again, the reason I set up testnet for the purposes of this video was to show you that the devices and Miningcore itself can hit blocks relatively easy. Obviously, we're hitting tons of blocks. And the same concept applies with Bitcoin, Bitcoin Cash, any other SHA-256 algo. And process is the same pretty much. And we've also got a nano over here. So we can go ahead and hop over here and we can do the same thing. So I can take the nano and we can point it to 2.168.1.80:3001. And we've got our Digibyte address. I'm going to call this nano. Go ahead and hit save here. And we have to reboot again on that device as well. Okay, it is connected. Hash rate's still ramping up, but you can see we already have 31 accepted shares here. And our ping to the pool is only 15 milliseconds. And this is, 15 to 20 milliseconds. This is really good. Obviously, the nano's connected to Wi-Fi. So our ping time is, given we're on Wi-Fi, is still extremely low, which is awesome to see. That's going to optimize the time that it takes for the block to get submitted to the network and accepted, which is really why you want the lowest latency possible there, which is one of the big advantages to running your own node. And we can see that it is ramping up. If we hop over here, it's still going to be updating the stats. This is going to take a bit for it to reflect. But if we go over to blocks, we're going to see, again, there's not much hash rate in the network, so we're hitting basically every block. You can see we've got 45 blocks right now. Now it's 46. You can obviously keep seeing that go up. And you're going to also see the network difficulty adjust. So network difficulty is going to keep going up here. Every time we hit a block, you can see it just went from 1.7 to 3.4. We basically just doubled the network difficulty because we brought that other device online. So just keep that in mind that if you throw a bunch of hash rate at it and then you take it off, it's going to take the testnet a while to adjust to that, where mainnet will adjust to it pretty quickly because of all the other hash rate on the network. Blocks will continue to get found. So we are hitting blocks, and you can see our nano has popped up over now. It's obviously still ramping up, but we should be getting about 4 terahash on this, about 1.2 terahash on this. You're going to want these. These are kind of averages over past so many minutes. So you do want to let this sit for maybe an hour or so before you look at the hash rates, because they should settle in. This one, we've got this clocked a little bit lower. So this one is currently sitting at about 1.03. 1.07 is what it expects. So that's right around on par. And then over here, we are, let's give this a refresh. We're sitting at 1.65. And let me just double check. We've got it in high mode. So yeah, it's still ramping up. So we're going to give this one, we'll give this a few minutes and make sure this jumps up to 4 terahash. And then we should be good. Okay, there you can see it jump back to 4 terahash. It's kind of settling in now. 75 milliseconds is our kind of the time from the nano to the pool. And you can see it's going to fluctuate here. So between 50 and 75 based on how much activity is going on my home network. I do provide storage on a bunch of storage providers. So I do see bandwidth spikes here and there. So for mine, yours may not fluctuate as much as mine does. During times of a lot of data transfers, it might go up to 70 milliseconds, but most of the time it'll be around that 15 to 20 mark, which is what we're seeing right now. So that is all there is to getting it up and running. You can see obviously we've hit 60 blocks so far. And if we go to blocks, you can see they're still confirming, but we do see 71, those first ones that we hit with the Bitaxe are now 71% confirmed. Once those go to 100% confirmed, it will actually issue a payout to the wallet that we are mining with. And again, we're in solo mode. We've got our fee is 0.01%. So that 0.01% will stay in the pool wallet. And then the other 99.99% will get paid out to the miner that found the block with that whatever mining address they were using. So that's all there is to getting that pool set up. Drop me a comment below. Let me know your guys' thoughts. If you have any questions, if you need help with anything, definitely leave them down in the comments below. This same strategy can be adopted to Bitcoin, BCH, as I mentioned, other SHA-256 coins as well. If you want me to cover those coins specifically in future videos, let me know down in the comments below as well.